Hi and welcome back to another video lesson. Today we're going to be talking about area of triangles. It's lesson 9.2. You need that one sheet of notes that I gave you today, and we're going to label it on your table of contents, page 91, area of triangles. You just have to fold that pink paper in half like a book, and we're going to deal with the front cover first and then go inside and solve some actual area problems with triangles as our shape of the day. Before we get there though, you take a rectangle and if you cut it in half, what shape do you have? That's the whole idea. And so you should have rectangle first and two triangles after you cut them. So that's the idea. And on your notes, going to draw that diagonal line to the best of your ability. Where's my straight edge? When you do that, you have turned a rectangle into two triangles. Now, we've talked about area of a rectangle. That is just area equals length times width. So on the side, I don't have as much room over there, so I'm just going to do it in the middle. I'm going to very briefly just figure out what is the length, what is the width of the entire rectangle. So I've labeled that. I'm going to do a quick pluck and plop with 6 and 4. And I'm finding that the area of this index card is 24 inches squared. But today we're not interested in rectangles and we're not interested in parallelograms. We're interested in the triangles. So I want you to shade any one of these triangles. I'm going to go with the bottom one. Because if we were just being asked, hey, what's the area of this triangle here? All triangles can be almost duplicated or copied and have another triangle kind of flipped over and we could make a rectangle. So if we know that the area of the whole rectangle is 24, we can cut it in half and get my purple triangle. 24 cut in half or divided by 2 is going to equal 12 inches squared. So that is a cool relationship between rectangles and triangles. The same applies to a parallelogram. So let's look at this. It's already divided for us, and we're asked just to find this yellow triangle that's sitting inside the parallelogram. So, like the previous lesson, we can find the area of the whole parallelogram and then cut it in half. So let's do that. 1, 2, 3, get my blue and red here. So this line down here is going to be my base, and the base is 8 units. Remember, we need to figure out what space is perpendicular to that. So I'm going to draw my H here. So this whole height is going to be 11. So I've labeled my parallelogram. I'm going to find the area of the whole entire parallelogram first. But area equals base times height, and that will be 8 times 11, which is 88 units squared. But again, I'm not interested in the whole parallelogram. I just want that half of the parallelogram, which happens to be the triangle. So I can cut 88 in half or multiply it by half, same idea, and I will get the yellow triangle, not inches, sorry, is 44 units squared. That's going to lead us into our formula. So let's go to that next. What we saw with parallelogram and rectangle is that we can find the area of two triangles because that forms a rectangle or a parallelogram, and then we can cut it in half and get the area of the one triangle that we're interested in. So the area of the triangle is 1/2 the product of the base and its height. Here we have a triangle, and we've noticed that we've labeled the base. It's perpendicular. Notice our chair is touching this line, and the difference here is that we can't use the top of the height. We have to look at where that right angle is for triangles. I know in parallelograms, opposite sides were parallel, so that didn't matter, but here, the base of the triangle is going to be where that right angle is literally touching. So this little symbol, that seat part of the chair, literally touches the base and touches the height. So this part touches the height and this part touches the base. That is going to be something that you're going to use often to figure out what's the height, what's the base. Look for that right angle symbol. What's the formula? Well, we're going to start off with our base and our height, which is the area formula for a parallelogram, and we're going to either multiply it by a half and use the fraction, or here's another way of writing it. Area equals the base times the height, and we're going to divide by 2. Remember, multiplying by 1/2 is the same as dividing by 2. So let's talk about different triangles before we get to the second box. If you go back to your vocabulary sheet, it's my second page, you'll notice at the top are the 3 different kinds of triangles. Go ahead and mark up the lines, meaning the isosceles triangle has 2 lines that are the same. The equilateral should have 1 hash all the way around, and the scalene has 1 of each, like I've done. So those are the 3 kinds of triangles, and there's also, forgot about the right triangle, you're going to see that one as well. So just familiarize yourself with those, and we'll go on to this second part. The base of a triangle can really be any of its sides. The clincher and which one is the base is looking at that height. The height is a perpendicular distance from that base, whichever one it is, to the opposite vertex. Now, what is a vertex? If you're not sure, go back to your vocabulary sheet. It's where 2 lines meet is a vertex. So here we have the base and the height of a right triangle like we saw before. And notice this right angle symbol literally ends at the base and touches the height. Here, though, we have the right angle symbol inside the triangle, and it's not one of the sides. So you will see that dotted line. So here's the right angle symbol. It touches the base here, and it touches this dotted dashed line, and this base is opposite this point. Over here, this base was opposite that vertex. And the other kind of triangle you'll see has the right angle symbol outside of the triangle altogether. We saw this a little bit with parallelograms as well. So here's our right angle symbol. This right angle symbol is going to touch the distance that the height is over here. But notice because it's outside, it doesn't literally touch the base, but it's actually on the same, if you were to extend the base, it would hit this part of the right angle symbol. So that is referring to this part of the triangle. Those are the 3 kinds of triangles you'll see. We'll talk about them with lengths as well. So if this is 4, this is going to be the base. Notice this is our right angle, and this is the distance between the base and the opposite vertex. Here's our right triangle here, just flipped a little bit, and here's one with our height that's inside. And notice the chair sits on the 5, and then the distance between the tip here and that 5 is our height. So that right angle symbol is going to be really important to pay attention to today. So let's start to find areas now. So I'm on the inside. Step 1, just like before, we're going to label our picture. So I'm going to pay attention to this dotted line, and I'm going to actually highlight it. I know yours is not red, but you can make it red or a different color. That distance, that dashed line, will be the height. So from the top of this triangle to the bottom of this triangle is 1, 2, 3 units. Again, this is no centimeters, inches, no specific unit, so we're just going to call it units. And the opposite to the vertex side of the triangle is the bottom, or this base. Notice the right angle symbol is touching the base and the height right there. So we have a base of 6, and I forgot to label this H for height. Once we've labeled, now we can write our formula. Our formula has to be one of those 2 forms. I'm going to alternate between the forms, and I'm going to start off with my area is the fraction half times the base times the height. Use colors to start off. So the area is what we're finding. Area equals 1/2. That's part of the formula. Now we pluck and plop. The base is 6. Our height is 3. Now because multiplication is commutative, does not matter what order we multiply these things in. If you prefer to take half of 6 first and then multiply by 3, that's great. If you want to multiply 6 times 3 and get 18 first, that would be fine, and then cut it in half. That's what I'm going to do. So area is going to be 1/2 of 18. Half of 18 is like taking 18 and dividing it by 2. So area equals 9. Because this is area and we're dealing with units, I'm going to say units squared. And we've found our first area. Here's one. The second one is going to be actually dealing with feet. So we have units and it's not in a grid form. We still have to label the height. And I'm going to look again to this right angle symbol. The right angle symbol is referring to this distance that's from this point and this top of the triangle. So that's going to be 9. And the distance, again, from that base to the opposite vertex, notice the right angle here, is going to be the height. So the 7 is the height. So start with your formula. I'm going to use now the base times height, then divided by 2 formula. Either one works. So the area is going to be plucking and plopping. The 9 is the base. The 7 is the height. Then divide it all by 2. I'm going to multiply 9 times 7 first and get 63. And then I have to divide that by 2. It won't work out perfectly. That's okay. As the numbers also get harder, you will be using calculators as well. So if you have a calculator, you want to pop that in, that would be fine. When you do divide, it does turn out to be 31.5. Because we're finding area and we're dealing with feet, we have the unit of feet squared. One more deals with decimals. Again, focus here is not on can you multiply decimals, it is can you find area. So we're going to label our parts first. Here's our right angle symbol and our dotted dashed line dealing with height. Here's the opposite vertex, meaning this is our base, our 12.1 is going to be our baseline. Notice our right angle symbol is touching that line as well, meaning our 6.4 is our height. We have our pieces. Let's plug them into our formula. One half base times height. Area is going to be 1/2. The base is 12.1. The height is 6.4. It does not matter which way you multiply these. If you want to take half of 12.1 first, you wanted to multiply your decimals together first, then divide by 2. Either way is fine. I'm going to multiply these decimals first, and I get an answer of 77 44/100. That is going to be cut in half. When we do that, you can, at this point, pick up a calculator and type in 1/2 or 0.5 times 77 44/100. When you do divide by 2, you get 38 72/100. Because we're dealing with meters, our unit will be meters squared. Now we're going to move into the second part of this where we're finding missing dimensions. Just like parallelograms, we're going to be given area and asked to be finding either the base or the height. So let's label to find out what we're going to be finding. This is the height. Notice it's one of the sides of the triangle, the right triangle, and then the base is touching this right angle symbol right here and right here. So that tells us our height, and we need to find our base. We know our area is 24. So when we are doing our formula, I'm going to use the half base times height again. We're going to plug in our 24 because that's our area. We have our half. We don't know our base, so I'm going to put that B in here. But we do know that we have a 6 for the height. When we're figuring this out, we know it's 24. Now we get into more of Chapter 7 algebra stuff. We know that multiplication is commutative. We could switch this around any which way we want. We can take the 6 and take half of it. Half of 6 is 3, or 6 divided by 2 is 3. So really, this simplifies down to 3b. If that's hard for you to see and you literally want to actually switch it, that's what it would look like. And then you take these two numbers and multiply them. 6 divided by 2, which is just 3b. So that's what I did in my head. I switched it around so that the half and the 6 were next to each other. I took half of 6, which is 3, and then the b would just kind of came down for the ride. Now I have a very simple equation here that I can solve for b by dividing each side by 3. 24 divided by 3 is 8, 3 divided by 3 is 1, and we have 8 as b. But we need to write that with the units. So the b is going to be 8 centimeters. So we have our answer of 8 centimeters for b. So here we have another, we're given the area. The area is 40 meters squared. Now let's look at our picture and figure out what we're trying to solve for. I noticed the b right away is down here. So we have this is the unknown, our base, and notice our height is going to be that dotted dashed line, which is the 8 meters, so that's our height, and our right angle symbol again touches the dotted line and touches the base. That's another way for you to know that you're dealing with the right parts of the triangle. So let's do our formula. A equals, I'm going to try just the BH divided by 2 formula to show you how that works. Filling in the same idea though, 40 equals, we don't know the B, so I'm going to leave that alone. We do know the H is 8, and we're going to divide all of this by 2. Now, if this is kind of messing with you, you could rewrite it, showing that 40 equals 8b divided by 2. You could just flip the order, but it doesn't matter, remember. So at this point, to start to solve this, I want to get rid of this denominator. So I'm going to multiply each side by 2. So that will get rid of the 2's over here, and I'll just be left with b times 8, or 8b if you prefer. And now I have 80 over here. Now we have to divide by that 8 on both sides, and that will leave us a b and then a 10. So our answer with our unit is 10 meters is the base. So here we have, again, area is 72 yards squared. Our height is one of the sides of the triangle, so there's no dashed line, but here's the right angle symbol. And again, the right angle symbol is touching the height, which is the unknown, and is touching the opposite side to this vertex. So we have 12 as our base. So here's our base. We have our pieces. Now let's plug them into our formula. Area is 1/2 the base times the height for a triangle. So now our area, we actually know, is 72. We're going to multiply that by the base, which is 12, and we don't know the height. So that's what we have to find. We can do this first part and simplify this by taking 12 and taking half of it, which is just 6. Now we have 72 equals 6h. The next thing we can do is divide by that coefficient, which is going to leave you with just an h on the right. 72 divided by 6 ends up being 12. So your h for your last one is going to be 12 yards with our unit. Wrap, if you could put your favorite kind of triangle, whether it's isosceles, equilateral, or scalene on the bottom of this page, that would be wonderful. I look forward to seeing you tomorrow to practice area of a triangle and finding missing dimensions of triangles as well. See you then. Bye.